Okay, good afternoon, everybody. Thank you for having us. We're really honored to be the first ones to kick off the event today. So my name is Torres from the software team at Arista, and this is Angebault, also from the software team from France, actually. And the two of us have been involved with SONiC for many years, and as one of the most heavily deployed platforms, we're really excited to share about what, one of the infrastructure issues that we've been faced and sort of present this to the community. Okay, our title is a little bit longer, a little hard to maybe understand what here, but pretty much this is what we're trying to avoid. This is an condition. This is what we don't want to happen. And I'm going to start talking about hardware and software life cycles, and Samuel will talk about some of the things that we've done to extend the life of our products in running SONiC as we keep moving here on with new technology, more bandwidth, and more use cases, as Dave said. So let me start talking about hardware life cycles. Typically, it takes a number of years to get a product out to market. At the point that the product management team has made a decision that this is what we're going to build, it still takes about 1 to 2 years to actually get that product out to market, to do the development work in hardware and software and all the different teams that are involved. The product specifications that are used at the time that the product is defined and designed are based on what we expect the product will be used for the next couple of years. Once the product is out, we are stuck, or we have to live with the constraint with those products for potentially 7 to even 10 or more years of deployment. And we're certainly starting to see this in the SONiC ecosystem now. On the other hand, in software, the life cycles are much shorter. Software life cycles typically are about 4 years from the time you release it to the end of life of that train. But it does still have that similar challenge of having to support for multiple trains the same product, potentially for that 7 to 10 or more years period. In SONiC, the release cycle is roughly 1 train every 6 months. So that's examples of this are 2020-12, which is the train that was cut off in December 2020, 2205, 2023-11, et cetera. And at this time, the end of life and end of support policy is somewhat ad hoc. It is restricted by, for example, how many bug fixes you can backport to the older trains, but also removing product support sometimes is challenging because you want to get the most out of the investment that you made many years ago, potentially. So here's the common slide that you will see in terms of product support. The vertical axis is the total bandwidth. And you will have heard of every couple years we're doubling the bandwidth in networking products. So whether it's starting with the 32 by 40 gig 1.28T, is that 32 by 40? Yeah. Product all the way to the 64 by 800 gig product in Tomahawk 5. You've heard all of those products getting supported, and potentially all of these need to be supported in one version of SONiC. Furthermore, in recent times, there are more companies adding support for lower bandwidth products. For example, last year, Arista introduced a 1 gig product based on one of the Broadcom chips. So you will see the bandwidth typically in all the marketing slides, but this is a table you don't usually see, which is a map of the memory and storage of the different products. And you'll see this period of time here over the last 10 years when, in the beginning, industry thought that memory and storage we can go kind of low on them, 4 gigs of memory and 2 gigs of storage, or 4 gigs of storage. And then more recently, we really treat them much more like servers at 32 gigs of memory or above and 250 gigs of storage or above. But as you can see in the middle over there, maybe it's hiding there, the 1 gig product that was introduced a few years ago actually still has a lot of cost constraints. And so we can't quite reach that high memory, high storage requirement. We have to keep within 8 gigs of memory and 16 gigs of storage. So I'm going to turn it over to Samuel to talk about the challenges that we've seen and what we did about it.
Thank you, Ryan. As you probably most know, the SONiC image is downloadable as a binary image, right? A bin or a SY. And within this image, it's going to be this image is going to be unpacked on your storage device, and it mostly contains 2 things, which is your root file system, which contains the host and the host host components, the kernel, and everything. And then the dockerfs.tar.gz, which contains all your containers, so all your applications. The rootfs remains compressed on the flash, so that's pretty convenient. But the dockerfs needs to be decompressed. So some numbers for a compressed Docker file system, it's like 500 megs lately. And once it's uncompressed, it's probably 2.4 gigs. So that's pretty significant. So we can already see that the product that has 2 gigs of storage can just not install a single image on it. Of course, once the image is installed, it is the installer gets removed. Sorry.
Oh. Technical difficulty. Just give us a minute. Yeah, I guess I can continue. I think I remember the next slide. But yeah, I mean, there are some expectation for anyone running SONiC is you pretty much want to be able to host 2 images on your system. I mean, you need to have your current image, the next image you want to boot into, and be able to roll back if anything goes bad. You probably also want to be able to install a new image without your switch dying on you. Which seems obvious, but when you think about it, at the moment you install your second image, so you're going to have your current image install, your system running, and you're going to have to download the image you want to install somewhere and extract it. So you need 2 unpacked images plus a compressed image plus all the space needed for your system to run properly. So that might not mean much for a system that has 64 gig of RAM and 240 gig of disk, but when you have 4 gigs of flash and 8 gigs of RAM, that is a difficult problem to solve. Yeah, so then I think I had a graph, not really meaningful here, but essentially this graph was showing the memory increase. The memory and the RAM usage increase over time from SONiC releases. And we started pretty low with like 2018-11, which was probably, I don't remember, but I don't remember exactly the numbers, but things grew pretty quickly, pretty rapidly from 2018-11 to 2012. And then from there, things kind of, like the growth kind of slowed down. But it keeps growing. I mean, software keeps getting heavier. Memory usage keeps getting bigger. Scale grows. Yeah. Thank you, Ryan. So yeah, so the graph is not up to scale, but as you can see, like 2018, like there's a year on the first for the first release, and then the last 3 releases are probably within 8 months. So it's not that meaningful, but yeah, like the trend is at the growth. So for some of the products that are like widely deployed and running SONiC in production, some solution have to be found, right? We want to increase the lifetime of these devices running SONiC. You cannot easily replace tons of devices like that. So the first idea that comes to mind, which seems simple, is like let's just reduce the image size. So that's the first option that we kind of looked into. And there are like some pretty simple things you can do, which is removing unnecessary files, so documentation, man pages, this kind of thing. Some smarter optimization you can do, which is hard linking. So you have Docker images that might install the same thing. So you can pretty much just hard link stuff. So you can make some optimization there. So all these are pretty common, but then you can also enter some use case or vendor-specific optimization. So you can remove support for a bunch of platforms you do not need in your environment. So that's removing all their firmwares, all their platform configuration. You can disable a feature. I mean, if you don't need NAT, why do you need the NAT container? If you have products without gearboxes, do you really need a gearbox container with the firmwares? This kind of thing. Some like, for example, the Linux kernel package is pretty big. Do you really need GPU drivers on a switch? So there are things you can definitely improve. Oops. So that was the first thing that we did. And the second thing that we did was to essentially find a trade-off between within memory and storage. So
keeping the Docker container stored on the flash, compressed on the flash, is manageable. So you still end up with an image that's like within a gig. Like each installation is a gig on your flash, so that's decent. And so what you could probably do is trade off some RAM and extract the containers at boot time in memory. So that's known as Docker in RAM. And if you have a lot of memory, you can just use a tempfs, extract this raw, or you can use a ZRAM to compress your containers in RAM. So that works pretty well, but you essentially have two big downsides. One being that the decompression at boot time, you take a hit at boot time for decompression, which might not be a problem for a cold reboot, but if you're trying to do a warm reboot, then that's going to impact your protocol timeouts. And the second thing that you probably was not that problematic some time ago, but that can become more problematic nowadays, is that changes made to Docker images or containers are no longer persistent. So if you're like using Kubernetes to deploy a new application on SONiC or something like that, don't expect them to be there if your switch reboots. And there were other attempts that we looked into to try and mitigate. Many of them were just not fruitful at all. Some were interesting, like using a compressed file system blob. So instead of having dockerfs.toutr.gz, you would just have like a compressed ZFS or compressed btrfs file system and mount it directly. But then you have a file system on top of a file system, so you take a latency hit and multiple lookups. So the performance was not good enough, and you would get like a boot within 10 minutes with tons of systemd service crashing. So that was not good. Other things did not pan out, like video. If you don't have like 64 gig of storage, it's not even going to work. So yeah, there are still some other things that we're looking into to try to improve the life expectancy of these systems with SONiC. There are some stuff that could be done. And some of them are probably tied to the requirements that I mentioned earlier. For example, the requirement to have two images stored on the flash. Is it a real requirement? If not, then that leaves a lot of space available. So that's, for example, one avenue that we're looking into at the moment. So here's the same chart as before, but with a small variant of the 2023-05 image, which is the slim one. And so as you can see, with applying, this one mostly uses the slim image mitigation. You can see that the image almost goes back to a size of 2019-11, which is like pretty decent. However, you can see that the memory usage doesn't go down as much. And this was just because we removed a bunch of features. But since the optimization, we're mostly getting rid of unused files, it's not really going to impact the memory profile that much. So we can see that memory is going to be a harder thing to tame. So this slide is a call to action, but I think it's mostly a call to attention. And making sure that newly introduced code essentially that newly introduced code doesn't like eat RAM too much. Making sure that there is a reason why it needs that much RAM, and trying to keep the size increase from release to release reasonable. There are like some services, for example, like the route check service, which is run by a cron job that's going to like spike 500 megs, or like it's actually relative to the scale, but it's going to spike like something like 500 megs every like minute or so. So if you are installing an image at that moment, well, you see the screenshot that Ryan put. And there are other things which is already pretty well respected, which is if you add a feature in SONiC, just make sure you have a toggle to disable it so that people can like get rid of it if they want to run in a reduced space environment. And I'll let Ryan finish up.
Thank you, Samuel, and great job improvising while the screen was not working. So in conclusion, the SONiC code base is maturing. It's been around for a number of years now, and many people are contributing to it. We need to manage the incoming feature and platform support, and think about the worst case platform constraints, which is basically the whole community, and implement some of these workarounds together. So obviously the product life cycles come into play, figuring out life cycles in how long we're going to support our products in SONiC. That's starting to come into play now too. All right, thank you very much.
Thank you. Any questions for the speakers? Okay.
Hi. Have you guys considered other containers besides Docker, like maybe Flatpaks or Snaps or even Containerd or LXC?
So no, that's not something we. So this is a really good question. No, this is not something we investigated. So I think the goal was to keep SONiC as close as it is. So we don't want to have too many. I think that the goal here is to not have different flavors of SONiC and try to make the code not care about which environment it's running on. So if you start running new container engines, you're probably going to need to update a lot of services, like SONiC host services. I think just imports Docker in places, so that means you have like a ton of things to do. With, for example, Docker in RAM, you just like hook into the init RAM-fs like where you mount your stuff, and the rest just behaves exactly the same. So the goal was to have the same feel when you use it, but underneath the image is smaller, for example.
I think I saw a few hands. Who else?
Did you have this gentleman here?
Yeah, hi. Did you check separating the image into the kernel, which is one part, and then the Dockers, and then when you, because usually the kernel doesn't change, right? So you can just if when you want a new version, what you really want are new Dockers, right? So did you explore that option? Just having an image that is one kernel, but two Docker, let's call it versions?
So you would keep the same rootfs, but different Dockers? I think the goal is to, you want the, so as Ryan mentioned, like the Debian releases essentially go end of life pretty quickly, I guess. So you want to get the new kernel supported by Debian. You want to get all the new tools supported. So you need to upgrade the rootfs eventually. Otherwise, you could probably deal with like downloading containers, migrating to the new one, removing the older one. But I don't think that's the plan. I think you want to build your new image, use SONiC installer, and go into the next one. You want to use the same process as you would with normal, regular SONiC image. Yeah, I think that's kind of the direction we went through.
Awesome. Any other?
So right now we went for the file systems. So we were using the app install, basically install as a regular Linux package. Do you think about like say just pick whatever we really needed and not install the package which we don't need it?
Yes. So yeah, that is part of the slimming down of the image. You just remove a bunch of packages that you don't need when you build the image. But so that gives you some savings, but that's not the most of it. I think SONiC is pretty lean by itself, so it's already doing a pretty good job. It's just that when you end up having tons of containers, like there are some Go binaries like these tend to like bubble up to like 20 or 50 megs easily. Like for example, everything that's telemetry or SONiC management framework, this kind of thing. Yeah, there are some stuff that are not really compressible, and that's kind of annoying.
I think we can take one more. Oh, looks like we have a question from the virtual audience.
The question is, what is root_check.sh?
Route check.
Route check. I don't remember exactly what it does. I just know how it consumes that much memory. I think it's just doing some show commands to dump all the IPv4 routes and IPv6 routes in JSON. And then I believe it's checking some properties to it. But it's taking like a full Redis database snapshot in memory and checking stuff with it. I mean, the code, all this code is open source, so I believe if the person that has a question just goes on github.com and on SONiC build image and checks for route check.sh, they're going to find it. It's either in SONiC build image or SONiC utilities.
Great. Thank you.
Thank you very much.